After that, now we take the methods of preparation of the amines. That is the vital part of this chapter, is the methods of preparation of amines. First is the reduction of nitro compounds. If you take nitrobenzene, better to take reducing agent iron with HCl, because of the large surface area it will act as a better reducing agent. Now I have to take 6 hydrogen, 2 times water lost, oxygen and hydrogen. Now it's very important compound, is you know very well, aromatic compound is the aniline. If I take CS3, CS2, NO2, nitroethane, it is nitroethane, 6H, we take it here, minus 2 times water, CS3, CS2, NS2. Ethanamine. Second is the reduction of cyanide. Cyanide in IPAC system is known as, what is that? Nitrile. Cyanide whenever reduced, primary amines are formed. CS3C triple bond N. What is the common name? Methyl cyanide. Alkyl cyanide. But an IPAC system, count the total carbon. Ethane and triple bond is the nitrile. Right. Add the 4H. In presence of any reducing agent, tin, palladium, nickel, then CS3, CS2, NS2. It is the ethyl amine. So methyl cyanide whenever reduced, primary amines are formed. Now I take aromatic C triple bond N. It is known as phenyl cyanide. It is called as benzene nitrile. It is known as cyanobenzene, or it is called as benzonitrile. All are one and the same thing because it is the single substitution. So common name and IPAC name and name will same. Undergo reduction in the same way. 4H, you take palladium. Now, what the product formed? Anyone tell me? Let me know the name of the product here. Benzyl amine, not aniline. No, it is benzyl amine. So, next is the third method, reduction of amide. RC double bond O NS2, acid amide. Take 4 hydrogen. In presence of any reducing agent, water is lost. RCH2 and NS2. You take CS3, C double bond O NS2. This is the ethanamide. Ethanamide. Undergo reduction in presence of reducing agent. CS3, CS2, NS2. What is that? Ethyl amide. You take the aromatic series. Benzamide. Benzamide. Now you go for the reduction in presence of reducing agent. water is lost, CS2 and NH2, benzyl amine. So reduction of cyanide done, reduction of amide done, then Hoffman's ammonolysis of alkyl halide. Hoffman's ammonolysis of alkyl halide. Now, next method is the Hoffman's ammonolysis of Rx. Mixtures of amines are formed. You take alkyl halide plus ammonia at 100 degrees Celsius in a seed tube apparatus. H and X is lost here. HX, R and H2, it's alright, 1 degree amine. Further you take Rx, another molecule of the Rx, same condition, 100 degrees Celsius. So it is 1 degree, now it is 2 degree amine. Further you add another H and X, R, 3 degree amine. Now again addition of Rx. Due to the presence of the lone pair of the electron, it forms a very important salt, tetraalkyl ammonium halide. It is called as tetraalkyl ammonium halide, or it is known as quaternary ammonium salt. Quaternary ammonium salt. So it's all right now. So all the methods of preparation, reduction of cyanide or nitrite, reduction of amide, reduction of nitro compounds, now Hoffman's ammonolysis are done. Now two important method of preparation is the Gabriel's thalamide synthesis. Now name reaction is the very important Gabriel's thalamide synthesis. You take thalamide, made to react with KOH or NaOH. Now N potassium thalamide, N potassium thalamide, it undergoes alkylation. You take methyl chloride. I can't take here aryl halides because aryl halides do not undergo nucleophilic substitution reaction. So important question here. I can't take aromatic here, only I take aromatic. Therefore, it's very important question here. Why we do not take aryl halides? Because you can say aryl halides do not undergo nucleophilic substitution reaction. N-methyl thalamide. pH is silent here. It is thalamide. Further, it will react with alkaline hydrolysis, twice NaOH, CS3 and 2 hydrogen. So main compound aliphatic amines are only obtained by this method, not aromatic, and ONO is still here. So the salt is obtained minus plus. Sodium salt of phthalic acid, or it is known as methyl amide. So Gabriel thalamide, you can frame language here कि when thalamide is made to react with KOH followed by alkylation and alkaline hydrolysis to form only and only aliphatic amines but not aromatic amine. That is why it is used to prefer the pure aliphatic amines. Therefore you have to select only the Gabriel's thalamide synthesis. So one question you can write here, this reaction is used to get only aliphatic primary amine but not aromatic primary amine, because aryl halides do not undergo nucleophilic substitution reaction. So there is possibility to get why aryl halides are not used in this method, because they do not prefer nucleophilic substitution reaction, because it is rich of electron and they are also rich of electrons, so there is possibility of repulsion. This question I have already explained you in haloarenes. Now it is all about Gabriel thalamide synthesis. Now last method of preparation is the Hofmann's bromamide degradation reaction. Last method of preparation is Hofmann's bromamide. So write down, very very important method, Hofmann's bromamide degradation reaction. I remember long back a question asked by the CBSE examiner, why is it so called degradation? Yes, degradation means if you take initially 2 carbon, always you get 1 carbon amines. If you take ethanamide, you take methylamine. If you take propanamide, ethylamine. Always amines are formed by the loss of 1 carbon. So it is known as degradation reaction. Degrade हो जाना, कार्बन एटम लॉस हो जाना फाइनली. यदि 4 से हमने स्टार्ट किया तो 3 के अमाइन बनेंगे, यदि 5 से स्टार्ट किया तो 4 के अमाइन बनेंगे. इफ आई टेक ब्यूटेनामाइड, what the final product? Propanamide. So definition is when acid amides RCONS2 are either aliphatic or aromatic, no problem. Acid amides are treated with Br2 and NaOH to form 1 degree amine by the loss of 1 carbon. That is why it is called as degradation reaction. I take the skeleton of this reaction RCONS2. Either it could be the aliphatic or aromatic, because R stands for aliphatic and AR stands for aromatic, right? CONS2 is the amide, you know it better. It's treated with Br2 and NaOH, or you can write, sometimes you can find in paper NaOBr. That means the bromamide degradation reaction. Remember it. Either you write Br2 NaOH or NaOBr. Both have the same purpose. RAR NS2. What is the amine? Very much it is the primary amines. We take one example here. Categorically we take aliphatic and then aromatic. CS3 C double bond O NH2. Ethanamide, Br2 and NaOH, minus twice NaBr, minus Na2CO3 to 4 NaOH you take it in order to balance the reaction. So CS3 NS2 methylamine. Here it has 2 carbon and here it has 1 carbon. So it is the benzamide, Br2 and NaOH to balance 4 times, minus twice NaBr, minus Na2CO3, minus 2 times water. Very important compound, aniline is formed. What is the formula of the aniline? CCH5NS2 or C6H7 nitrogen. Here 6 plus 1 7 carbon. Here it is the 6 carbon. So there is loss of 1 carbon atom. So this is Hoffman's bromamide degradation reaction. One exercise question based on Hoffman's bromamide degradation is complete the following reaction. I take here A treated with ammonia and heat it to form B, right? And B on treated with Br2 and NaOH or NaOBr to form C, and the name of the C is C6H7 nitrogen. So obviously it is the aniline, and aniline contains the 6 carbon. So here the compound must be acid because it is the benzoic acid. Water is lost here. Very much benzamide is made to react with Hoffman's bromamide degradation reaction and aniline is formed. What the name of A, B and C? C is already given you a structure. So dear students, it's aniline. B is the benzamide. And finally there is degradation of the 1 carbon atoms. It is benzoic acid whenever made to react with ammonia to form benzamide, followed by treatment with Br2 and NaOH or NaOBr, sodium hypobromite. That means you will get primary amines. Either it could be aliphatic or aromatic. So Hoffman's bromide degradation is quite useful in making conversions right now. So this is all about methods of preparation of amines.